Hello everyone, welcome to my YouTube channel. My name is Precious. So in this video we want to have some examples of problems under equation of circles. You recall that we said that if you are given the center of a circle as HK and then the radius as r. Okay, so then we were told that the standard equation of a circle is x minus h all squared plus y minus k all squared equal to the square of the radius. All right, so the implication is that if you are given the center and the radius of your circle, you can actually form the equation of that circle. You recall that in the previous video, we actually saw how to get the center of and the radius when the equation is given. So now we are going the reverse direction. What if you are given the center and the radius? Can you obtain the equation of that circle? So starting from the A part, here we are given the center as 2 minus 1 and then the radius as 4. All right, so all we need to do is to plug in these values into the function. So let's quickly do that. So we have x minus, now from here now we have that our h is 2 and our k is negative 1. So we'll have x minus 2 all squared, and that is plus 4 minus minus 1, which will become plus 1 all squared, and that is our r now is 4. So we'll have 4 is the power of 2. So this is actually the standard form, but of course it's okay that you put it in the general form, where I said that you can actually get by expanding the two brackets you have here and then taking everything to the left hand side. So let's quickly do that. By the time we expand this, we'll have x squared minus 4x and then plus 4. Okay, please ensure that you convince yourself that that is true by expanding x minus 2 by x minus 2. So by the time you do this expansion, you should be able to get this particular function here. So, and then for the other bracket, we are going to have y squared plus 2y then plus 1, and so everything is now equal to the right hand side, which is 16. So I'll be trying now to collect everything together, and that's going to give us x squared, so y, and which is equal to 0. So this is the required function or equation of the circle whose center is 2 minus 1 and radius is 4. So let's quickly look at the second one. Or okay, yeah, let's go ahead. So for the second one now, we are told that our h, which is this, is negative 1 over 3. And so when you sum minus minus, that will be plus, and that is squared plus here we'll now have y. Of course, this is will also be plus 5 all squared, and that is equal to our radius now is the square root of 6, and so we are squaring this. Now we'll try to open our brackets, and when we do that, we are going to have x squared. If you expand this one, you are going to get 2 all over 3x, and that is plus you now have 1 all over 9. Please ensure to also do that to be sure that that is correct. And so now on this other side, you have y squared plus this will be 10y and then plus 25 to be equal to, on the right hand side, this square will take away this square root, and so we'll just have 6 left. Okay, so what do we do from here? So we'll try now to simplify, and by simplifying I mean to gather the values we have. But even before doing that, we can first of all clear all the fractions by multiplying through with the LCM, which is 9. So if I multiply through by 9, I will have 9x squared, and then 9 multiplying this, 9 will cancel 3 and you have 3 left. 3 times 2 is 6x. 9 multiplying 1 over 9 will give us 1, and then this will be 9y squared, and this other one will have 90y. And of course, by the time we multiply, but before we multiply this, if you take this to this side, it will be negative 6, and 25 minus 6 will give us 19. So we'll now do 19 times 9, which will give us 171, and everything now is equal to 0. So at this point, we can now gather our function or equation properly, and that's going to give us 9x squared. So we'll bring the y closer to it, which will be 9y squared, and then we have 6x plus 90y, and then gathering the constants, which is 1 and this, we'll now have 172, and that is equal to 0. And this is our second equation as required. Right? Now, there is a second example I would like us to look at here. This is another beautiful critical example that will allow you to think. It says, find the point of intersection of the circle. And so we are given a circle here and then the intersection of the circle and this line. So structurally, something like this: you have a circle and a line crossing it, and so you can see there are two intersection points here and here, and that's why the question says we should find the points of intersection. Okay, so let me assume that the coordinates are x1 and y1 here, and then the second point is x2 and y2. So what's the implication of this? So what it means is that at the point of intersection, the values of x and y will be the same for the circle and also for the line. So what it means is that if you get this point, if you substitute your x and y from this point into this function, it is going to make this equation to be true. And if you substitute the same values of x and y here, it will also be true for this line. Okay, and that will also be true for the second point. So, and that's what we're going to use now to solve. And how are we going to do that? So if our y and x are going to be equal at that point of intersection, that means I can substitute this y into this equation, into this other function, and it will be true. So anywhere I see y in the circle, I'm going to remove it and replace it with x minus 1. So I'm going to have x minus 1 here squared, and that is minus x, and then minus 3 into, remember that my y is x minus 1, and everything now is equal to 0. So with this equation, I can get the value of my x and then use it to now solve for my y. So let's quickly do that. So this is x squared plus, expanding this bracket, I will have x squared minus 2x then plus 1. And here we have negative x, and if you open the last bracket, you get minus 3x and then plus 3, and that is equal to 0. Okay, so from here we can then collect like terms, and this will give us 2x squared. Gathering all the x terms here, we are going to have negative 6x, and then gathering all the constants, we will have positive 4, and that is equal to 0. Now recall that from what we have here, that this is the coefficients are even, so we can actually divide by 2. So divide every term here by 2, and that's going to give us x squared minus 3x plus 2 equal to 0. So from what we have here, we can actually now solve quadratically to get our x. So what do? Look for the by factorization, the factors are going to be negative 2 and negative 1. So you recall the easy approach I taught earlier. You can actually look at that. Open two brackets, put your x, since the coefficient is 1, put your x values here, and then just attach those constants that you got. So you have negative 2 and negative 1, equate everything to 0. So what it means is that either this is 0, which is x minus 2 is 0, or x minus 1 is 0. And from there, we can actually then see the value of our x as 2 or positive 1. So we have gotten the 2 points or the two coordinates of x. So we need to now to get our y. And if you come up here, we are going to make use of this relationship. From there, we are seeing that our y is equal to x minus 1. So what it means is that when our x is 2, then our y is 2 minus 1, which is equal to 2, and then sorry, which is equal to 1. And when our x is 1, then our y is 1 minus 1, which is equal to 0. Therefore, the 2 points we are looking for are, so when x is 2, our y is 1, and when x is 1, our y is equal to 0. So these are the 2 points of intersection of the two equations. That's the equation of the line and the equation of the second. You can check that what I said earlier is true by substituting any of the points into the two equations and see if the equation will be true. Let's check the first point. If I put 2 as my x, I'm going to have 2 squared plus my y is 1, which is 1 squared, 1 minus x, which is 2, minus 3 times 1, which is 3. Let's see if this will give us 0. 2 squared is 4 plus 1 is 5. And here we have minus 5, which is actually equal to 0. If we put the same point into the line, is it going to be true? Our y is 1 equal to x is 2 minus 1. And of course, this is true. 1 is equal to 2 minus 1. So you see, even when you try it with the second point, it will be true for the equation of the circle, and it will also be true for the equation of the straight line. All right. So this is what I said to share with us in this video. Kindly subscribe to our YouTube channel and give a thumbs up to this video if you like it, and share our YouTube channel to your friends, your colleagues that will have need of it. We'll see you in our next video. Bye.